Two different particles doing simple harmonic motion. I'll draw myself a diagram. Blue one, green one. Okay. And I'll just have the centers of their motion directly opposite. Okay with that? So let's put the the blue particle and the green particle, and that's what I'll be picturing in my head. That'll be the picture in my head. Two different particles doing simple harmonic motion. Okay, and then I go, okay, two particles pass through the centers of oscillation at the same instant. So they both at like t equals 0 as an example, they're both passing through the center at the same time. Cool with that? And they're both currently at their Vmax. Now, they next reach their greatest distances from the center after 2 seconds and 3 seconds respectively. That's good information, because think about this. Now, I don't know which one's which, do I? I actually haven't got a clue. See the way I made the amplitudes different and everything? I've no idea if that's accurate, so in that case, I'm sort of just going to make them the same size, just so there's no bias in what I'm doing. So they're both the same length currently, but that won't be the same at the end. So what we're thinking is different amplitudes, different omega values. Is that okay with you guys? Now, when you move from here to here, how much of your entire cycle have you done? Nope, not half. Think about it. 1, 2, 3, 4. 4 quadrants. Remember a sine function has 4 quadrants. So this would be like A, S, T, C, sort of like that. It's always it's always in fours. So that is a quarter of its cycle. Okay? So T equals 3. And then that's 1/4 of its cycle. So what you reckon? So I think the period is 12 for one of them. And when it's t equals 2, oh sorry, stickler for order. It's 2. 2's the first one. So it's 1/4 t is 2. So what's t? Remember I said 2 seconds, 2 seconds, 2 seconds, 2 seconds. So t is 8, isn't it? T1 is 8. Okay? Now, what's the formula for period?
2 pi over omega.
And what is the period? 8, isn't it? And then bring up omega, bring 8 down, and you get omega equals pi over 4. So I already have A1 and W1. Actually, I haven't got A1. I do have W1, whatever. Is that okay with you guys? Now, what about A2? 1/4 of t is what, lads? 3 seconds, isn't it? So, it takes 3 seconds to go from here to here. 6 seconds, 9 seconds, 12 seconds. So that means that T2 is 12. Okay? And 12 equals 2 pi over omega. Omega equals 2 pi over 12. Omega equals pi over 6 in blue. Now, how are we going to get the amplitude? But what does it give us here? What does it tell us there? After 1 second. The x values are equal. So 1 second after their motion, okay, they're both the same distance apart. Does that make sense? But what that means, one of them obviously, which one's the faster one? The higher the omega, the faster it oscillates. Which one's the faster one? W1 or W2? W1. So here's what happens. W2 travels here, but I reckon W1 came and bounced back again, so that they're both the same distance away from the middle section after 1 second. Their x values are the same, correct? So that brings us to t is 1. X values are the same. starts from the centre of its motion, doesn't it? So if it starts at equilibrium, what am I using, sine or cosine? Sine or cosine, lads? Sine. Cool. Now, for argument's sake, x equals a1 sine, what did I say for 1 again? Pi over 4t. And t is 1. And that will equal a2 sine pi over 6. Once again, times 1. Yeah? And then we just want the ratio of their amplitudes. It doesn't say whether I want a1 over a2 or a2 over a1, does it? It doesn't specify. So you see the answer is 1 over root 2. But another answer could be root 2 over 1, because they didn't specify what order they should be in. So I'm just going to give them a1 over a2, just because that's the way whichever one was named first is a1. So here's what we'll do. We'll bring the a2 underneath the a1, and we'll do sine pi over 6 divided by sine pi over 4. And what's sine pi over 6 divided by, so what's a sine 30 divided by sine 45? Root 2 over 2, which is 1 over root 2. So I'd actually get root 2 over 2 if I was using my calculator, which is perfect answer, but it's also the same answer as 1 over root 2. Alright, that took